guys, welcome to another lecture from Introductory Statistics. And today we will learn how to create a probability mass function, a probability mass distribution with the help of a couple of questions. So my first question for you. Suppose, let's consider a situation where whether the next person buying a computer ends up buying a laptop or a desktop model at a certain electronics shop. Okay. Let's take our random variable x to be in this case equal to 1 if the customer purchases desktop, 0 if the customer purchases a laptop. Well, we know that if 20% of all purchasers during that week select a desktop, then what is the probability mass function for x? When I'm asking you what is the probability mass function for x, that means I'm asking you to create the distribution for this random variable x. Now, x is taking only two values. X can take values 0, 1. 0 is the value that x is taking when somebody is buying a laptop, and 1 is the value it's taking when somebody is buying a desktop. Now, we very well know that 20% of all purchasers that we purchase desktop. That means 80% are purchasing laptop. So 1 is the value x takes when somebody is buying a desktop. So 1 is a value that comes up with 20% chance. That means the probability associated to that is 0.2. And therefore, the probability associated to 0, that is, if the customer is buying laptop, it's an 80% chance. So 0.8. So how would you write down the probability distribution? This is your probability distribution. And how can you write down probability mass function? A mass function generally is denoted, either you can call it fxx, you can call it px. Basically, it is associated to the probability x equal to x. And it can be written like the way we write down functions, right? So here we have fixed values. We have a value when x is 0. The value is 0.8. If x is 1, the value is 0.2. And if it is any other value, x is not equal to 0 or it is not equal to 1, that is for any other value or otherwise, the probability will be 0 because it's only taking two values. Now you guys tell me, can you recall what random variable this is? We have done this kind of situation before. A random variable that takes only two values, that is success, which could be divided like success, failure. Only two values. You can define success as 1, failure as 0. This is a Bernoulli random variable. And the following is the Bernoulli distribution for you guys. Okay. Let's also take up another example to clarify on what we have been working on. Consider a group of 5 potential blood donors, A, B, C, D, E, of whom only A and B have O positive blood group. 5 blood samples, 1 from each individual, will be typed in random order until an O positive individual is identified. Let's create a random variable from this experiment. Let's take it as y. And let's take y to be the number of typings necessary to identify O positive individual. Now, the first question you need to ask yourself is, what values can y take? Y can take, see, it might so happen that I just take the first typing and first typing turns out to be O positive. So therefore, y can take value 1. Now you have to think, when will y take 1? Now, only A and B are O positive. Only A and B are O positive. So that means the first typing that I'm taking is either of A or of B. Okay. If not the case, then that means maybe the first typing that I take is not O positive. So it could be anything C, D, E. Okay. But the second one turns out to be O positive. Second one is either A or B. So therefore, I can take 2. I can take the value 2 because it might so happen that I'm taking 2 typings and I'm getting O positive. I can even take the value 3 because what can happen is that the first 2 times the typing that I'm getting is not O positive. Now it could be C, D, E. So for the first 3, for the first 2, I'm getting either C, D, or E. But at the third position, I get either A or B, which is O positive. Now Y can also take the value 4. In this case, what can happen is the first 3 that I take, the first 3 typings that I take is not O positive. And the fourth one turns out to be O positive. You should ask yourself here, can Y take the value 5? Well, absolutely no. Why? Because think about it, there are 2 people with O positive. If say the first O positive, I am getting the first O positive when I have typed 4 people. That means the fourth person is O positive and the first 3 are not O positive. If the first 3 are not O positive, that means it must be C, D, E for the first 3 positions, and then it could be A or B. But then automatically, since at the fourth position, I'm getting the first O positive. At the last position, that is fifth, would automatically be O positive, because try to understand why is the number of typings necessary to identify an O positive individual. So that would be the first O positive individual. Okay. So therefore, Y can only take values 1, 2, 3, 4. Y taking 5 will not make sense. Now it's very important to understand how to find the probabilities attached here. So find the probability mass function of F. How will we do that? What do I require for probability mass function? I require probability Y equals to some value Y. That means I need to find out, if I may call it, Py, I need to find out P1, I need to find out P2, I need to find out P3 and P4. I've already explained to you that Y can only take value 1, 2, 3, 4, because if till we are going till 4, then fifth one automatically is O positive. There are 2 O positive. Now, when can Y take the value 1? So probability Y equals to 1. That means at the first position, the first sample that I'm taking, the first sample typed is either from A or B, because that is only, O positive. So this means this is equal to probability A or B typed first. So there are how many total samples that we have? We have 5 samples. Out of the 5 samples, 2 samples, A or B, that means 2 samples out of the 5 samples. So 0.4 is the probability. Now, what is the probability that Y is equal to 2? Probability Y equals to 2. You need to understand the meaning of that. That means at the first position, neither A nor B was there. That means at the first position, you could have C, D, E. And at the second position, the second typed is either A or B. Okay. And the first typed one is it cannot be A, B. It could be C, D, E. So the probability we need to find C, D or E typed first and then A or B at the second position. So understand this probability very carefully. This is equal to probability C, D or E first. Now one of them is already selected. Okay. So multiplied by probability A or B, second, typed second, given C, D, or E, typed first. You need to understand that this is a without replacement case. That's why this conditional is very important here to understand. See, because for the second position, when you are selecting AB, there is one less sample because one sample has already been taken out. One sample has already been typed. So the probability that C, D, or E is typed first is 3 out of 5. Total 5 choices are there. And out of that, 3 choices I have. Multiplied by probability A or B is chosen second, given that at first you have already chosen something out of C, D, E, right? So if one thing out of C, D, or E, one sample has been taken out of selection, that means I'm only left with 4 samples, right? To type. Suppose, for example, say C was selected here. Then C is not in the next selection. Okay. So therefore, in the next selection, the second selection, A or B should come out as an answer, either A or B, because that's O positive. So I have only 2 favorable cases out of how many total cases? Out of 4 remaining cases. So that's what will be the probability here. It will be 6 by 20. Or in other words, it will be 0.3. Okay. Similarly, P3. P3 means probability Y is taking value 3. That means we must have taken 3 samples in order to get O positive individual. That means the first 2 are not O positive and the third one is O positive. So that means probability C, D, or E is typed first and second. And then A or B in the third position. Okay. So this will be equal to, if you have understood the second case, then this should be very easy for you guys to understand. For the first time, I have 3 options out of 5. For the second time, now 1 out of C, D, E is out of selection. It's out of selection from total outcome as well as the favorable outcome. Okay. So 3 by 5 into 2 by 4. And now the third time, I'll be left with 1 out of C, D, E. I'll be left with 1 of them. See, for example, C and D are selected, then E is left out. Okay. So in total, I will have A, B, or E, could be D, could be C, different cases. Now, that means in total, now I'm left with 3 samples, out of which the favorable case, 2. A or B, right? So this will give you 4 upon 20, that is 0.2. In the similar fashion, what will be probability 4? Now, probability 4 means probability Y is equal to 4. Now, when is Y equal to 4? Y is equal to 4 means the first 3 are C, D, E. So this is equal to C, D, E, all done first. And then you'll be left with only A, B. So that means this will be equal to 3 by 5 into, for the second position I have 2 by 4. Then I have 1 by 3. And the next time it's sure because I'm only left with A and B. So it's sure that I'm going to get an O positive. It doesn't matter whether it is A or B. It doesn't matter. So it is equal 1. The probability that O positive, we are not bothered about A selected, B selected. We're bothered about O positive selected. Will be 1, right? So therefore, what you will get is 2 upon 20, that is 0.1. Hence, your probability mass function will look like something of this sort. You can take Y as value 1, 2, 3, 4. And the probabilities associated to Y equals to Y. For 1, it was 0.4, 0.3, next 0.2, and next 0.1. Observe the total that you will get here, 0.4 plus 0.3 plus 0.2 plus 0.1 is equal to a total of 1. That means these were the only possibilities associated to the correct probability that you figured out. Y cannot take any other value. So you can write it down as a function as well. If you're writing down as a function, the way we write down functions in general. So you'll write down if y equals to 1, if y equals to 2, if y equals to 3, if y equals to 4, and otherwise. So otherwise, of course, it will be 0. No other possibilities. And for these, you have fixed probabilities 0.4, 0.3, 0.2, 0.1. So with this question, I have also made you guys revise how to calculate probability, simple probabilities. See, when we are working with random variable is something associated to an experiment only. So ultimately, random variable takes a number, takes some value, and there is a probability attached to that value it is taking. Now, when you're trying to find out that probability attached, it is the same process as you find probability in case of any simple probability question or probability experiment. Okay, so remember that that's your base. Finding probabilities for any simple situation or a difficult one, that's your base. Random variable comes in later. When you are noting down a random variable, you will have to ultimately find out probabilities only. Okay, so try to strengthen the conceptual ability to find probabilities at various stages, okay, in various experiments. Once you are strong with that, random variable is just a part of it. Thank you very much. I hope this will help you guys.